In this episode, we will work on a new task that will hopefully settle any confusion about the units on our x and y axes. In this episode, we work to create a graph in the context of a moving sidewalk. Imagine you're on a moving sidewalk that is 10 meters long. In this episode, we attempt to create a graph that represents a relationship between your position on the moving sidewalk and your distance traveled.
So there's no change in height
Right.
because you're on just like a flat moving
So we're just
walkway.
on length.
Yeah. So then it would be like, would it just be a horizontal line?
No, because we can still make a it doesn't have to be y equals height, right?
Right. What could it be in this context?
Length,
Okay.
because we move 10 meters in length. So if this is length, so we can write length now.
Sorry.
And that's length,
Okay.
and then this is distance. Because this journey for distance traveled 10 meters in.
Is that not the same?
Yeah, isn't
unit?
it the same thing? Because it's in meters, because this is in meters.
Because like, let's say that, okay, so if this is the walkway and you start here. Sorry.
That's a great stick person. That's really nice.
Thanks.
If you're on a 10-meter walkway, so you're this person and you go 10 meters and you're over here now. Oh, it's a different color.
You change colors on this walkway.
Yeah.
Like green is this green person is your initial point and your blue person is your final point. And the entire walkway is 10 meters. You've traveled 10 meters.
Okay.
And whether you travel forward or you travel backward, it's 10 meters because it's not asking for displacement.
What would this graph look like if we were graphing the length versus the distance traveled?
You're right, wouldn't it be horizontal? If this is 10.
Mm-hmm.
And it would literally just.
Yeah.
Oops.
Okay. So you started this time at kind of up on the y-axis. Can you talk to me about that point you circled?
So we set the y-intercept at 10 meters since that is like the constant length of the walkway. Like that's not going to change. It's like it's the given. So the length of the walkway isn't changing. So you would constantly be at the 10 meter mark for length. But then distance, we just drew a horizontal line because that would be like as you're walking, your distance is increasing even though you're still staying at the on the 10 meter walkway.
Okay. And where would this graph end then?
At 10.
At-
I think. Right? This would be.
Mm-hmm.
Am I wrong?
No, I think that's right.
So you get to the end of the walkway and
Your distance you've moved is 10 meters.
okay. So I love that. Your distance traveled is 10 meters.
Yes.
Zoe, when you were describing this point, you were describing it as the length of the sidewalk is kind of fixed. And I definitely agree with that. That's kind of what the context is telling you. What about our journey on the sidewalk? So have we always gone 10 meters on our sidewalk?
No, you have to start at 0.
Okay.
You have to start where the green person is. So even though you're given a fixed length, your distance it would still be 0.
Okay.
And then as you go down the walkway, either direction, you're increasing your distance to end at 10.
Yeah, so that means your graph makes sense. Because if you put like other units here, like 2. Like if you did that.
But you're not at 10 meters the entire time.
Oh, you're right.
Because you would start at you'd start at 0, travel like this, and then this is your end point at 10. Because you've traveled 10 meters in distance, and you've traveled the entire length, the 10 meters of the walkway.
How do you feel about that, Giselle?
I love it.
You love it?
I love it.
Very good.
And then you can, unlike the other graph, this one is in meters too. Then I'm pretty sure.
Unlike the other graph.
Because the other graph that we did earlier, like the other one, like the one up top, that one,
Do you want me to move up to it?
yeah, we didn't know what distance was because we're moving up. Does that make sense though?
This one adds a second variable in it.
Yeah, the other one doesn't because although you're comparing two variables, they have the same unit.
But then, is this not just a moving walkway just turned on its side? Shut up.
Wait, this one. Wait, you're right. But we're going up. This one we're comparing height per distance.
Height is length, but vertical.
You're right.
So it sounds like we have a realization.
And the graphs look exactly the same.
Okay. Can you guys walk me through your discovery?
So, after doing the moving walkway problem, we kind of realized that even though the elevator is moving vertically, that's the same thing as like length, just in a different direction.
Okay.
So, the set length or height is 10 meters, but as your distance is increasing, it would also be in meters. Because even if it's not proportional, you would still end up traveling the final 10 meters to get your last point to be the same. Does that make sense?
You're right. Oh, I love it. Okay,
Do you want to add anything to that?
let's just put this. They're exactly the same, both of the graphs. Because, yeah, height and like they're exactly the same thing. Just
Just
goes
one's
up.
vertical and
one's
one's
horizontal.
horizontal.
Great.
Great.
That was a great realization. I think it's weird to think about. I think thinking about height in terms of a distance, I don't know, we don't typically go straight up. So thinking about that in terms of a distance is kind of weird.
Wow. Good job, Zoe.
Great teamwork.
They finished their graph. The idea of units can be tricky, but this episode was an important deep dive. Have you ever had to construct a graph that had the exact same units on both the y and x axes? It's pretty uncommon. In the end, Zoe and Giselle were able to wrestle with this idea and conclude that both x and y are measuring lengths, one a height and one a distance traveled. As such, both can and should be measured in meters.